Hi guys, good morning to all of you. Yes, can you hear me? Yes, anyone please, can you hear me? Yeah, so thank you. So we'll continue our session. Yes, today topic. Yes, so previous class, yes, big data challenges, data storage, data processing. Yes, these topics were discussed. Data storage, it's a distributed data storage. Next, data processing, it's a parallel processing here. Multiple servers will process the data. Data storage, data always distributing onto multiple servers, not single one here. See here, data storage, see multiple servers. One file always it will try to distribute on multiple servers here. Name node takes care of data distribution. Name node will distribute data into multiple nodes in cluster. Okay. Once again, yesterday we discussed some example here. Suppose, yes, data loading. File with 100 GB data loading. Okay, suppose first node itself is having more free space. For example, here 1 TB free space. For example, 1000 GB free space means 1 TB, 1024, 1 TB, right? First node itself having 1 TB free space. Yes, around 1000 GB free space. What is size of the file? Only 100 GB. That means first node is capable of storing this 100 GB, right? First node is capable of storing 100 GB. Okay, even it's capable of storing 100 GB, never storing in the single system. Never storing on single system. Yes, if it's storing on single system, what happens here? Yes, that becomes like a traditional system. Yes, what happens in traditional system here? One server, only one server has to process the data, right? Only one server. So time taken, if it is only one server, it's time taken, right? Suppose in Hadoop also here, Hadoop also data, all this data, whole this data storing into one node. That the one node means that only one node has to process the data. Only one server has to process data. So same like a traditional system. No difference between Hadoop and traditional system. That based like a traditional system. Only one server has to process. So only one server processing all this data, time taken, right? So Hadoop never will do that. Hadoop never doing that here. So name node taking your data here, distributing onto multiple nodes in cluster, distributing onto multiple nodes. The data will be distributing onto multiple nodes. Just distributing onto multiple nodes in cluster here. It will distribute. Of distributing here, while data processing in multiple nodes, yes, process the data here. Multiple nodes will process the data. Multiple nodes processing data. Yes, node 1, node 2, like this, multiple nodes. Multiple nodes will process data. Same data processing by the multiple nodes. Okay, if multiple nodes are processing data here, that gives them more performance, right? In traditional system, only one database server has to process data. Yet, but when come to Hadoop here, data will be distributing onto multiple nodes in cluster. For example, here there is users information. Users information. This contains some 20 lakh of records, right? All the 20 lakh of records distributing onto multiple nodes in cluster. Okay, how that distribution here? Distribution is, yes, the distribution is yes, how much percentage? 5% of existing data, right? 5% of total data, the distribution process. 1 second here. Yeah, here explains. Yes, 5% of total data on each node. 5% of total data. So data distributing onto 20 nodes. Always you try to distribute onto 20 nodes. That is default algorithm. Suppose very big data getting in that case, Yeah, that becomes half again here. 2%. 2% of 2%. Okay, right? Means main number of nodes. That will store into main number of nodes. See, I'm repeating once again here. Suppose file 1 with 100 GB data loading. File 1 with 100 GB data loading. 100 GB. This 100 GB data distributing onto multiple nodes in cluster. Distributing onto multiple nodes in cluster, right? How that distribution takes place. Here distribution here. So you can name node just taking 5% of total data. What is total data here? 100 data. So 5% of 100 GB is nothing but 5 GB simply here. Okay. So 5% of total data on each node, right? That means how many nodes total? 20 nodes, right? Yes, 5% of total data. So 5%, 5%. How many 5s? It's 100 here. 20, right? 20. That means your data distributing under 20 nodes. Okay, that's a case of 100 GB, around 100 GB like this. So a very big data is there. Suppose 1 terabyte of data is there. Very big data. 1 terabyte of data. Yes, now that converts into half. 5% divided by 2 here. 2%. Still petabytes of data is there. Again become half. That again become half means 1%, 1% like this. Now here 5%. So here 5% of total data. So what is 5% of total data? Let us see this here. See here, file 1 with 100 GB data. File 1 with 100 GB data. Okay. Size of each block is 128 MB. Okay, size of each block is 128 MB, right? See, size of each block. In second version of Hadoop, size of each block is 128 MB. In first version of Hadoop, size of each block is 64 MB. Yes, 1.x version 64, 2.x version 128 MB. We are going to work on second version. 1.x version we are not going to use. Okay. Now 2.x version, second version of Hadoop we are going to work here. Yes, even in our projects also we are using second version of Hadoop here. So we are going to work on second version of Hadoop here. So second version of Hadoop. Okay, I will be explaining second version of Hadoop here. In second version of Hadoop here, the size of each block is 128 MB. Size of each block. So what is that block here? See, hard disk divides into multiple blocks. Suppose this hard disk, block 1, block like this, multiple blocks, right? Many blocks. Hard disk divides into multiple blocks. Yes, here size of this block is 128 MB. Size of this block is 128 MB. 1 second, someone is unable to hear me. Yes, that guy is unable to hear me. Unable to hear me. Rejoin the session. Yes, if anyone unable to hear me, rejoin. That guy Chetak Singer. Okay. Now he's okay. He came to online. Yes, he's there. Okay. Yeah. So that hard disk divides into multiple blocks like this. Hard disk divides into multiple blocks. Maybe HDFS data or traditional file system. In any case, hard disk always divides into multiple blocks. Yes, hard disk, your system hard disk divides into multiple blocks. Maybe your laptop. Okay, maybe data center system, any computer, hard disk divides into multiple blocks. Any computer, hard disk, there is a hard disk, that the hard disk divides into multiple blocks. Okay. Yes, in this hard disk storing some file system, right? Like Linux file system, Windows file system, and Hadoop file system. Okay, if it is Linux and Windows file system, that case size of each block is 4 KB. Linux, Windows, Linux and Windows size of the file, yes, or block is 4 KB. Yes, traditional file systems like Windows, Linux based size of each block. Size of 4 KB. It's a 4 KB. Yes, if it is Hadoop, it's a 120 MB. Size of each block depends on version. 1.x per MB. Second version and third version 128 MB. Okay. So size of this, the size of block. So disk divides into multiple blocks here. So the size of each block is 128 MB. In Hadoop on HDFS, size of each block is 128 MB. That point is clear, right? So size of this block is 128 MB. Okay, fine. Now data. How much data we are loading here? Yes, let us see that data loading. In data loading, how much data we are loading here? File 1 with 100 GB data loading, right? File 1 with 100 GB data loading. So when loading 100 GB data here, 100 GB is equal to how many blocks? Yes, size of each block equal to 128 MB. Then 100 GB equal to how many blocks? First, let us check 1 GB. 1 GB equal to how many blocks? 1 GB equal to how many blocks here? So 1 GB is equal to 1024 MB, right? 1 GB is equal to 1024 MB. 1 GB equal to 1 GB data is equal to 1024 MB. Okay, see these things already we discussed in previous class. Yes, these concepts. See, 1 byte equal to 8 bits, 1 KB equal to 1024 bytes, 1 MB equal to 1024 KB, 1 GB equal like this. These concepts in previous class we discussed already here. These concepts already were discussed. I think these are basics. Anyone well known for everyone here. Okay. Yes. 1 GB equal to 1024 MB. 1 GB is equal to 1024 MB. Now let us come to topic. So 1 GB. 1 GB equal to 1024 MB. Okay. Then 1 GB equal to how many blocks? How many blocks here? Here. Yes, 1024 divided by 128, right? 1024. See, here size of each block is 128 MB. 1 GB equal to 1024 MB. So then 1 GB equal to how many blocks? So 1 GB data means is a 1024 MB. 1024 MB. Yes, divide by 1024 MB divided by 128 MB is equal to 8 blocks. So 1 GB equal to 8 blocks. Then 100 GB how many blocks? 800 blocks. That's it here. Suppose in 1 direct each block is 64 MB. 60. That case 64 MB. Then what the? Yes, if it is 128 for 1, it's 800 bucks. 128, 800 bucks. For 64 MB, how much here? 1600 double. That's it here. Okay. So like this. Now storage in this. So the data is multiple nodes in cluster. So 800 bucks of data. That 800 bucks of data has to distribute, right? So 5% of total data. That means 5% of 800 bucks. 5% of 800 bucks is 40 blocks, right? 40 blocks in the here. 40 blocks. That means totally 20 nodes. 20 nodes, right? The data. Yes, here 40 blocks, here 40 blocks, here 40 blocks. It will try to distribute on 20 nodes. All the 20 nodes, right? So 40 blocks of free space. Yes, here storing. Suppose here 40 blocks not available. Suppose only 30 blocks available. No, it won't use that. Not here. Next one which is having 40 blocks. Next 40 blocks. Next 40. Next 40. Next 40. Next 40 like this. Like this, if you try to distribute and multiple nodes in cluster, equally distributing, right? So means data distributing onto multiple nodes in clusters. That means multiple nodes will process your data. Yes, if it is traditional system, what happens here? Only one server has to process data here. In traditional system, only one server has to process the data here. But in Hadoop here, multiple nodes will process the data. Okay, multiple nodes will process the data, right? So that gives them more performance. That's it here. Yeah, this is what we discussed in previous class. Right? Yes, next today topic is yes, here data storage. See here data storage in Hadoop. Data storage is a distributed data storage. In Hadoop, data storage is distributed data storage. Means file splitting into multiple blocks and storing on multiple nodes in cluster. So data storage is multiple nodes. Yes, traditional system only one system, only one server. In Hadoop, data storing on multiple servers. In traditional systems, only one server. Next, when come to data processing here, traditional system only one server has to process the data. Same data in Hadoop, multiple servers. Around 20 servers will process the data here. Same data. Yes, in traditional systems, only one server. Same data in Hadoop, 20 servers will process the data. So one server working, 20 servers working. There is a lot of difference, right? Yes, 20 servers working, that is the more performance, obviously, correct? So even big data also can process within short time because of 20 servers processing here. Okay, fine. Yes, next. Yes, high-end hardware. Let us go for next. So these two topics were finished already here. Okay. Now today we should discuss about these topics. So high-end hardware and very large files, backup and recovery, disaster management. So these are the big data challenges. Yes, apart from that, other challenges are there. That other challenges we'll see next year. Now high-end hardware. What is this one here? High-end hardware. High-end hardware. With Hadoop, high-end hardware is not necessary. Yes, you can go for cheaper hardware, commodity hardware. See, high-end hardware, when it comes to disk, yeah, they say RAID disk. They say RAID disk and the commodity means cheaper here. Commodity disk. They say commodity. RAID disk and commodity disk. Okay. So what is RAID disk? What is commodity disk here? Yes, in our system we are using commodity disk, means cheaper hardware. Commodity means cheaper. It's a cheaper hardware. Okay, commodity disk is a cheaper hardware here. Cheaper hardware, very cheap this is. Okay, commodity disk. Yes, in our systems we are using commodity disk. Commodity means cheaper. Okay, one second. RAID disk. Cost this is. RAID disk. Yes, 10 times costlier. 10 times costlier than yes. Cheaper commodity disk. Is a 10 times cost. RAID disk is a 10 times costlier than commodity disk. Right? Okay. Yes. Let me show that what is RAID disk here. RAID disk. Yes, RAID disk. Yeah, this is RAID disk. Images. Yeah, this is RAID disk here. The storage. Yes, RAID disk. Yes, in RAID disk. Block 1, block 2, block 3, block 4 like this. Disk 2, block 1, block 2, block 3, block 4 like this. Now this RAID disk. Now here commodity disk and RAID disk. What's the difference here? Yes, in case of RAID disk here, suppose suddenly OS failed or system crashed, no loss of data, we can recover. RAID disk data can be recovered. RAID disk data, yes, even disk failed, no problem, we can recover the data. But commodity disk, if disk failed, we can't recover the data. We can't recover. Okay, not possible. Yes, our systems are commodity disk, right? If we are using commodity disk, we can't. Suppose your disk crashed, you can't recover data. Just recently, 1 month back, my disk was crashed due to heavy loads. Continuously working here, my disk was failed. Disk completely crashed, but I was unable to get the data here. Okay. Yes, here luckily my data is having drive in my maintaining drive here. For all the data here, for Hadoop related data and like Java related data, all that documents I'm maintaining a drive. In drive, I'm maintaining all this. So because of that, yes, I was safe that time here. Yes, 1 month back when disk crashed. Yes, I purchased new system. It's a new system with a high-end system. This is yes. So here the cheaper hardware. There is no security for data, loss of data. Once disk failed, loss of data. But when come to RAID disk, no loss of data. Even disk failed, no loss of data. See, commodity disk cost 1 TB. 1 TB disk is equal to just 1,000 rupees. You can get it here. Yes, in Hyderabad market, we can get for only 1,000. 1 TB disk. Same 1 TB disk, if it is RAID disk is a 10 times means 10,000. 10,000 RAID disk is a 10,000 rupees. 1 TB data for to store 1 TB data here. 1 TB disk is a 10,000 rupees here. So 10 times this disk is 10 times. Now we are using RAID disk, we are using commodity disk here. RAID disk, real time production environment. Production. Suppose in our systems we can use cheaper hardware, no problem. Even development as a company, project development, you can use cheaper hardware, no problem, no issue with that. Okay, but production. production data. Yes, we're storing real data. Production data means real data. Yes, in data centers, it's a production server, right? Production servers are real data. For example, here, yes, Aadhaar ID. Yes, Aadhaar. Yes, Aadhaar ID, right? Aadhaar ID. For India, Aadhaar ID here. Yes, other information. There are 2 data centers. That is production data here. So banking data, that is real data, right? Real data must be secure. So that case using RAID disk. Production servers always using RAID disk. Means suppose if it is small data, suppose server with 10 TB disk is enough. Server with 10 TB disk means yes, to build this server, the disk 10 TB disk. So 1 TB 10,000 rupees. 10 TB disk how much here? 1 lakh. So to build that disk here, 1 lakh required, right? Next, others and all this may be more cost. Okay, if you read this here, 10 TB data, for 10 TB data here, 10 TB data, yes, 1 lakh of rupee required, right? Just 1 lakh required. 1 lakh required, right? 10 TB small data. Suppose big data getting, yes, big data getting, yes, we need more space, right? Not 10 TB space, maybe 10 petabytes of space required. Yeah, that much of space, that much of disk, it's a costly. High end, right? Yes, if data is more, we should go for high end, right? It's a high end. Yes, probably the high end, right? Yes, big data, high end. Yes, if using high end hardware, if using RAID disk here, what happens? Cost, right? More expenditure. Yes, if using RAID disk, small data, RAID disk can be used, no problem. Okay, less amount of, yes, this less amount we can write. So big data means yes, more TB disk required. Yes, so disk space, more volume of disk required. More volume is yes, automatically that expenditure is more, right? So high end, yes, with Hadoop, high end hardware is not necessary here. With Hadoop, high end hardware is not necessary. Okay, RAID disk is not necessary here. Traditional systems like Oracle database server, MySQL database server, compulsory RAID disk you have to use. With the traditional database servers here, we should use RAID disk. Suppose if not using RAID disk, what happens here? Yes, if system for disk face loss of data. So for the recent production servers always using RAID disk only here. Oracle database, MySQL server database, Microsoft SQL or traditional database, they use RAID disk. Production servers always RAID disk. Okay. Yes, when come to Hadoop here, Hadoop production servers. Traditional systems production servers using RAID disk. Okay. Yes, traditional systems production servers using RAID disk. But when come to Hadoop here, RAID disk is not necessary here. We can use commodity hardware here. Cheaper hardware you can use here. Commodity, cheaper hardware you can use. Reason, I'll tell you. So this is Hadoop cluster, right? Okay, here data node like this. In this data node, data stored. Suppose this node is failed, disk failed, loss of entire data. Loss of entire, because it's a commodity disk, right? Because of commodity disk, cheaper hardware here, loss of total data. Loss of total data, right? That case. In that case here, what's the solution from the Hadoop here? What is the solution? Yes, how it is possible to use commodity disk in the Hadoop here? Let us see this. Here in Hadoop, they say concept of replication factor. They say concept of replica. Replica means copy. Yes, replication factor. Replication factor. So what is replication factor here? Replication factor. Yes, what is replication factor? Replica means copy. Replica means copy here. So default replication factor. Default replication factor is yes 3. Means for every data, Hadoop name node generate 3 copies. For every data generating 3 copies. For every data generating 3 copies. Default replication factor is 3. That means for every data generating 3 copies. Okay. Suppose 1 copy is here. Next second copy is here. Next third copy is here. Somewhere different locations. Suppose your file data 100 GB data. Yes, if you loading 100 GB data, for example, 100 GB data loading. When you loading 100 GB data, it becomes 300 GB. When you loading 100 GB data, that becomes yes 300 GB. Suppose data is on data loading into 20 nodes. 20 nodes, right? Then how many nodes total here? 60 nodes. 20 multiplied by 3, 60 nodes. Finally, the data distributing on 60 nodes. That means 3 copies. 3 copies. For every data, it generates 3 copies. Replica means copy. Default replication factor is 3. For every data, it generates 3 copies. Yes, first copy here, second copy somewhere in the cluster here, third copy somewhere in the cluster. Suppose first copy disk crashed, no problem, because we have the backup data, right? Second copy is available. Second copy disk crashed, third copy is available. No problem with this, right? Then backup copy is available here. Even disk fail, no problem. Second copy, third copy is available, right? So commodity hardware also can be used, no problem with this. Yes, RAID disk is not necessary. High-end hardware is not necessary. With Hadoop, high-end hardware is not necessary. That means 10 times of expenditure can reduce here. Okay, with Hadoop here, yes, with the disk only 10 times of expenditure we can reduce. So we can go for the commodity hardware. I think it's clear, right? With traditional system, RAID disk required because data recovery purpose. Yes, in Hadoop, it's not necessary. Hadoop will maintain 3 copies for every data. 1 copy fail, second copy, third copy is there. Any one of the copy fail here, 2 more copies available. 2 more copies available. So RAID disk is not necessary. RAID disk is not necessary. Yes, we can use cheaper hardware. Okay. Yes, I have seen this, my experience. Okay, cheaper hardware, commodity disk. We can configure the Hadoop cluster. Okay, right? Yes, I worked for 2 years in data center. Okay, that is my experience here. 2 years in data center. Yes, 2013, 2014. I was in US, Chicago data center. Yes, 2013. Yes, 2014. 2 years. Yes, for our client purpose. I was in US on L1 visa at Chicago D-World company. So for them, I worked in data center for 2 years. That time I have seen, yes, how the cluster is configuring. Okay, yes, I worked practically here. Yes, we have configured clusters. Okay, yes, very good experience for 2 years. Okay, after that I came to Hyderabad. Yes, continuing development, Hadoop project development. Okay, right. Yes, mainly for the purpose of Hadoop only, I went to US for 2 years. I was in US for 2 years for only for the purpose of Hadoop. Okay, yes, Hadoop taking Hadoop KT. After taking the Hadoop KT here, started working on Hadoop. That time, data center clusters setup, next Hadoop project deployment, all this for the purpose. For the first project, we have taken for 2 years almost. First project was taken for almost for 2 years. Okay. Second project onwards, it has become very easy for us. Very easy for us. Okay, right? Yeah. So here, now here, so commodity hardware. So when come to hardware, yes, we can use commodity hardware here. High-end hardware is not necessary because backup copy is there. For every data, Hadoop will maintain 3 copies. So if any 1 copy failed here, 2 more copies you can use. So even disk fail, no issue with that. So high-end hardware is not necessary. Next, very large files. Yes, what is this very large files here? Very large files. Sometimes there is chance of generating very large files. Big data files, right? Chance of generating very large files because of huge number of transactions every day. Suppose let us take Amazon, yes, online shopping, right? Or Facebook. We take this. Suppose this is a log file. This is a log file. Suppose per day using 1 log file. Suppose application designed, yes, daily 1 log file. Application designed to maintain daily 1 log file, right? Suppose at the beginning of application, suppose Facebook, suppose 10 years back, Facebook started. 10 years back, Facebook, right? Yes, that time at this time of starting Facebook, that log file is very small file because of less number of customers. Facebook users, right? Yes, 10 years back, 10 years ago, Facebook users are very less, right? Very less means less number of transactions. If less number of transactions, log file is very small file, right? Now, Facebook is having 220, not 220, around 250 crores of users. 220 crores, 250 crores of users working on the Facebook, right? So this much of is working, what happens here? That log file obviously will be more size, right? More size. Okay, 10 years ago, less number of files, less number of transactions, daily one log file. Daily, how many users are working? All that logs information log file, right? That file is very small file. But nowadays, many users are using Facebook, right? So every user log information, log into log file. So there's a big data file, right? The chance of generating big data file. Okay, big data file, right? Yes, if it is big data file here, yes, traditional systems like a traditional, yes, traditional file systems, file systems like Windows or Linux, Okay, traditional file systems like Windows or Linux. These file systems are not in a position to store huge amount of data in a file. Yes, the maximum size of the file that can be created is only 65 GB in Linux space or Windows space. Windows. Okay. Yes, actually Linux is 65 GB here, but Windows is less, not 65 here. Windows Max supports only 25 GB, not more than that. Windows maximum size of the file is maximum 25 GB here. Linux is 65 GB. Yes, how Linux is 65 GB, I can explain this. It's not an issue here. I can explain what's the reason here. Behind this, some inode concept is in Linux. Is inode concept in inode some array of 13 pointers here. Using that, maximum size of the file that can be created in Linux space is 65 GB. 1 second. I'll show in my Linux document here. Linux document. Yes, prepared Linux document. Yes. Yeah, this is inode concept in Linux space here. Array of 13 pointers here. Yes, total size. This is maximum size of the file that can be created in Linux space is around 64 GB. Yes, more than that it fails. You can't. That's Linux concepts. Okay. Yes. This document prepared for the Linux. Just I'm giving training for Linux and Hadoop. Only these two things, not others here. Linux and Hadoop training. Okay. Yes. Just two batches taking, evening one batch taking. That's it here. Rest of the hours working for office. Okay. Yes. So this is 60, yes, 65 GB, around 65 GB. Yes, that can be created. Okay. Yes. So 65 GB, right? So what data is more than 60 GB? What happens? Linux system fails. Yes, real time chance is there. Okay. More than 65 GB. See, in Facebook per day, 4 petabytes of data generating per day. Okay. Some log files, there's chance of generating big data file. Chance of generating big data file. Right? If big data file generating here, yes, Linux and Windows file system fails. Yes, cannot accommodate big data file. Suppose here 65 GB data file generating here, yes, Linux base becomes very slow. Slowly data processing here. That much of size is not recommended to use in traditional file systems. Only small files are recommended. Big data files are not recommended. Okay. Yes, here in traditional system, one file on only one system, only one computer, right? In traditional system, one file on only one computer here. So one file storing on only one computer, not multiple. When come to Hadoop, what happens here? File divided into multiple parts. Those are distributing on multiple nodes, right? In Hadoop, file storing on multiple nodes, multiple computers. Then file splitting, right? File splitting simply, right? Okay. Suppose here, for example, here 100 GB data files getting, right? Generating 100 GB data file generating. Yes, 100 GB not required storing one system here. Multiple systems. How many systems? 20 systems, right? Divided by 20, that means 5 GB. Yes, on computer, on each computer storing only 5 GB. 5 GB very simple, right? Very easy. Okay, 5 GB also very easy, right? See, in our Hadoop applications, we are going to process 10 to 20 GB data. Okay, yes, 10 to 20 GB data files are there to process. Yes, in our class topics, I'll be using 10 GB data file. I'll be using for processing data, big data processing, big data examples. Yes, how mapped job working on big data. So that case, 10 GB data I'm taking care. 10 GB data. Okay, so it's generating 10 GB data and process, right? Yes, 10 GB, 20 GB also no problem here. But here when come to only 5 GB enough here. Your data, that 100 GB data distributing on 20 nodes, right? Means one file dividing into multiple parts, storing on multiple nodes, right? That means on each node only 5 GB. 100 GB not required storing one system, right? Only 5 GB enough. Bigger distributing, right? Yes, in traditional systems, one file, only one computer. That means total 100 GB data file has to store in single computer, right? But not possible. Okay, suppose file with 100 GB data. File is having 100 GB data here. That 100 GB data file, 100 GB data file has to store on only one computer in case of traditional system. This whole 100 GB data file, 100 GB data file has to store on only one computer in traditional system. But Hadoop is not like that. Okay, 100 GB data file generating single computer, not possible. Not possible here. Yes, so traditional systems fails. Yes, 100 GB data file creating with 100 GB traditional system simply fails here. Yes, sometimes chance is there. Yes, file generating with 100 GB data. When file is generating with 100 GB data, traditional system fails. But Hadoop will not fail. Reason, in Hadoop, one file never storing on one computer. That file storing on multiple computers in Hadoop cluster. Multiple computers means 20 computers. 5% of total data, 5% 5%, that means 20 computers, right? That 100 GB file is splitting into 5 GB, 5 GB, then storing 20 computers. That means then on each computer, how many? Only 5 GB, not 100 GB. So what traditional system, whole file has to store in single computer. In traditional system, whole file, that 100 GB data file has to store on single computer, on single computer, on single computer. But when come to this, yes, Hadoop not required. Multiple, the data storing on multiple computers. It becomes easy, right? So Hadoop can handle very large file also. Hadoop can handle very large file also. Reason here, in Hadoop, file storing on multiple computers in the Hadoop cluster. One file storing on multiple computers. In traditional systems, one file only one computer. Okay. No, file can't break. In traditional system, file cannot be break here. We can't break the file in traditional file system. Like Windows Linux file system. Windows file. For example, Windows file. This Windows file, this file cannot break. Only one computer. Two computers not possible. But Hadoop possible here. Hadoop possible. So one file storing on multiple nodes in the cluster, multiple computers in the cluster, right? That's the reason it can handle very large file also. Hadoop can handle very large file also. Reason, one file breaking into multiple parts and storing on multiple computers. That's the reason it can. It's a distributed data storage. So for that reason, it can. So because of that reason, it can handle very large file also. This is one more challenge with big data. Okay. Yes. So here, yes, with the Hadoop big data or data storage, any amount of data we can store into Hadoop class. There is no limit. There is a limit. By adding nodes to existing cluster, we can store any amount of data. There is a limit on storage of data here. Like data processing, even big data also can be processed in short time here. Even big data also processed in short time. Reason, multiple servers. Multiple servers will process the data. It's a parallel processing. Because of parallel processing, multiple servers processing data here, even big data also can be processed in short time here. Fraction of seconds finishing, milliseconds. Sometimes even nanoseconds also finishing it. Milli, micro, nano, even nanoseconds also data processing will be finishing here. Okay. Next, very large files. Yes, sorry. High-end hardware. Yes, with the Hadoop, high-end hardware not necessary. That means RAID disk is not necessary. We can go for commodity disk here. Commodity, cheaper hardware. We can use cheaper hardware. Okay, right? Next step. Yes, backup and recovery. Yes, let us come next. Backup and recovery. Okay. Yes. Yes, in case of RAID, suppose RAID disk failed, no problem. Yes, RAID disk failed, no problem. You can take the backup. Yeah, RAID disk data can be recovered. RAID disk data can be recovered, but complete disk cannot be recovered. Yes, suppose if using RAID disk with the Hadoop, what happens here? Yes, maintenance is more, right? Big data, for big data purpose using RAID disk. Suppose 10 TB disk you can purchase. Suppose 100 TB disk is very costly, right? Maintenance will be more care. If it is RAID disk here, maintenance is more. For that reason, yes, Hadoop in Hadoop RAID disk is not necessary. Hadoop can use commodity disk also. Commodity disk cheaper hardware. RAID disk is not necessary. I think clear, right? With Hadoop RAID disk is not necessary. We can go for cheaper hard disk here. Okay, RAID disk is costly. Maintenance will be more. Okay, that is not necessary here. So Hadoop we can use cheaper hardware also. Fine. Next, backup and recovery. Yes, interesting topic, backup and recovery. Yes, now backup and recovery. Here also we'll see traditional systems versus Hadoop here. Traditional systems versus Hadoop. Yes, backup and recovery. Backup and recovery. So what is backup and recovery? Let us see this. Backup and recovery task here. Backup. Traditional systems. Traditional database. So first let us see traditional systems. Later we'll see Hadoop. Traditional systems. Like database. Oracle database, or for example, Oracle database server. So this is a Oracle database server. Yeah, this server generating data every day. Now that data has to take backup compulsory here. Suppose server failed, loss of data, right? For that purpose, backup. Yeah, this is a backup. Backup required. Yes, in backup here, there are two types of backups. In traditional system, there are two types of backups. First one is incremental backup. Incremental backup. First one is incremental backup. Next one is full backup. Incremental backup, full backup. Incremental and full backup. What's the difference between these two? Incremental backup is nothing but a daily backup. Yes, why called as incremental backup? I'll tell you. Full backup means it's a weekly backup. Full backup is weekly backup. Incremental backup is a daily backup. So this is a daily backup. It's a daily backup here. So daily taking backup here. Just full backup, it's a weekly backup. So weekly, weekends taking this weekly backup. Now, why this is called as incremental backup? Let us see this. Incremental backup. Suppose Monday taken backup of data. Monday, right? Next Tuesday. Monday taken backup. That backup data storing into one disk. Now Tuesday same job running. The backup job is running, correct? The Tuesday backup, Tuesday data will happen to that Monday backup. Appending to existing already Monday backup stored into one disk. Okay. Same job running next day. Now Tuesday, that job will take the data. That data will happen to existing data. So Monday plus Tuesday. That's okay. Next Wednesday job. Yes, Wednesday here. Next Thursday data. So like this, appending like this. So one by one appending data, right? Yes, incremental, increasing by yes, incremental like a yes, like a here. Suppose in C language some plus plus, right? C language job plus plus. What is yes increment? Yes, incremental, right? Increasing by one. Increment operator, increment decrement, increasing by one, right? Just increasing by one. Okay, that is nothing but incremental concept here. So increment by one day backup, right? Monday backup, Tuesday backup, yes, Wednesday backup. So you get daily backup, that's adding, right? Means increasing the data. Incremental, this colors incremental here. Friday, yes, next Saturday, yes, finally Sunday, right? This is daily backup data will happen to existing one. Existing data plus that new data. Now this existing plus next data. So existing plus next day. So one day data increment integrate. So this is called incremental backup. The backup data increasing here. So this is called as incremental backup. Finally, this whole thing is a whole week data. So this is called as incremental backup. Yes, next, what is full backup here? Full backup is weekly backup. Means generally on Sundays. On Sundays, yes, because Sunday is not a business hours, that time taking backup. That is full backup, right? This is okay. Yes, in our company we are using both incremental backup jobs are running, full backup jobs both are running here. Daily backup jobs are running and weekly backup jobs are running because safety purpose. Safety purpose. Okay. Now here, okay, taking incremental backup, so fully backup, okay, fine. Suppose in case of incremental backup here, for example, daily backup job. Yes, daily backup job. Yes, daily backup job. Yes, the job may be running for just 10 to 15 minutes, hardly 10 minutes only here. 10 to 15 minutes. Daily backup job is running for 10 to 15 minutes. Suppose if it is big data. Small data 10 to 15 minutes. Big data maybe 1 to 2 hours. Yes, if it is big data backup, we say 1 to 2 hours. Okay, small data means 10 to 15 minutes enough here. If it is big data, 1 to 2 hours required. 1 to 2 hours. Right, okay. That is daily backup, right? Suppose fully backup. Yes, full backup or fully backup, calling us fully backup, weekly backup. Fully backup. In case of fully backup, weekly once run rate, weekly data. So this is taking weekly data backup, right? That case what happens here. Fully backup, the job. Yes, fully backup job. Suppose small data, fully backup small data, just taking 1 to 2 hours max. Yes, I know that practically here. Yes, in our company here, weekly backup. Yes, small data case taking only 1 to maximum 2 hours, not more than that. So big data, 10 hours also. Yes, some jobs are running for 10 hours. Supply chain management is most important, most core module in our company. Supply chain management. That ATM machines, manufacturing industry, for them, supply chain SCM data is more important for them. Yes, when taking SCM backup, that will take 10 hours. The jobs are running for 10 hours. Okay, weekly backup job running for 10 hours. Okay, now here daily, yes, so you get these backup jobs running, right? Who will run the backup jobs? Who will run here? Yes, this is scheduling. Jobs will be scheduled. Yes, in our company we are using Tidal, Cisco Tidal tool here. Cisco Tidal tool for job scheduling. Tidal tool, right? Cisco Tidal, it's a tool for scheduling jobs. Okay, so that tool will run the jobs regularly. Yes, daily so and so time already pre-scheduled here. So once schedule is done here, so once time reaches, the job firing automatically here, taking backup automatically. Suppose backup job failed, the job failed here. Okay, now this tool generates one mail and sending to DBA, sending to database administrator. DBA get it. Yes, now DBA gets receiving that. Yes, that errors. So for reason, yes, backup failed. That reason sending to DBA. Now the DBA guy has to open that script, the database script. Okay, yes, backup script. At the DBA, the DBA guy has to open the backup script. Now he has to identify the issue. Yes, backup script. Actually, we will develop the backup script. Database backup script. Database vendor will provide the backup scripts. Suppose if it is Oracle database, if it is Oracle database, then Oracle Corporation, yes, Oracle Corporation will provide it. So Oracle Corporation will provide the backup script. Take that backup script here. Next, you have to customize. The backup script has to customize as per your database. What kind of customizations? Yes, I know that very well here. Backup script customization here. Yes, in customization, some details you have to provide. What's the location for database? Where your database is available? That's server information. Database location. Next, what's the instance name? Database instance name. Database location means IP address of database server. Database instance name. Yes, is it? Yeah, supply chain management instance or something, production data, something like this. That instance name. Next, schema means login schema, like Scott and Tiger, something like that. Yes, in production server, some user ID password, that information. Next, what's a table? Now, which table, on which table you want to perform backup? The table name. Next, from the tables, how many columns are available? Which column want backup data you want here, like this. So table is having 20 fields. All the 20 fields taking backup here. 20 fields of data taking backup, right? Sometimes 20 fields may not be required. That kind of customizations. What is what table name? Yes, how many columns? What are the columns? Type of columns? All that information you have to provide. That is nothing but a database backup script customization. That has to customize as per our database. Who will do that here? DBA. Database administrator will customize this. After customization, backup script starts here. It's not required to write any backup scripts. So already predefined backup scripts available. Okay, Oracle Corporation giving that backup script that has to customize. That's it here. Means making modifications. Then you have to utilize. That's it here. So DBA, you will run the database, right? The backup script. Yes, prepared backup script here. Now running it, daily running. Suppose any issue raises. In backup script, any issue raises, the backup job fails, right? When backup job fails, the DBA has to address that issue. Just simply will address the issue here. He'll fix that issue. After fixing issue, then restarting backup script. So you can every time of failure, he has to address that issue and he has to restart the job, right? Okay, so what's happening here? Yes, manually backup. Manually backup, it's a risk. It's a risky task. So if any failures are there, that issue has to address. So manually taking care. So it's not easy here. The DBAs, many DBAs have to work here. So it's an expenditure, right? Expenditure to company here. Okay, right? So manual backup. Yes, if it is traditional systems, manual backup required here. It's a risky task. With traditional systems, backup task is a risky task. Risky task, many resources involvement and costly and time waste and all these, right? Yes. Then come to Hadoop. With Hadoop, backup is not necessary. Yes, backup is not necessary here. Hadoop takes care of backup here. Hadoop takes care of backup. Hadoop takes care of backup here. Yes, how it can take care of backup? Let us see that. Okay, Hadoop takes care of backup. Yes, taking backup is not necessary. In traditional systems, every data we should take the backup manually. But in Hadoop, it's not necessary. Hadoop takes care of backup here. How? How it takes care of backup here? Same just now we discussed here previously, replica. There is a concept of replication factor. Replication factor, right? Replication factor. There is a concept of replication factor. The default replication factor. Default replica. Yes, default replication factor values. Replication factor values 3. By default, 3 copies. So by default, Hadoop will create 3 copies. Suppose if you don't want 3 copies here, you can make it single copy also. So minimum, yes, minimum replication factor is 3. Minimum replication factor, sorry, default replication factor is 3. Minimum replication factor is 1. Yes, you can change it here. Default replication factor is 3. If you want to change it, we can change. We can configure. We can make it 1 also. Minimum replication factor is 1. Default is 3. Suppose if you want more than 3 also, then maximum. Maximum replication factor. So what's the maximum replication factor? Your 512. 512 copies you can maintain this. Yeah, this entry question. What's the default replication factor in? Yes, for HDFS 3. What's the minimum replication factor? 1. What is maximum here? 512. Okay, right? Yes. The default is 3 here. Automatically 3 copies maintained here. Suppose if you want more than 3 also, yes, we can configure it. Maybe 4, maybe 5, maybe 6. That depends on requirements. Okay. Suppose if you don't want 3, you can make it 2 copies also. 2 copies for the purpose of backup. 2 copies or 3 copies. Still, if you want 1, only 1 also you can maintain this. Okay. So the replication factor, right? So 3 copies. For every data, Hadoop generating 3 copies. For every data, 3 copies. First copy, second copy, third copy. Suppose first copy fails. no problem. Second copy is available and third copy is available. So backup, Hadoop takes care of backup automatically. So that manual backup is not necessary. With Hadoop, manual backup is not necessary. Hadoop takes care of backup automatically. 1 second. Yes, Hadoop takes care of backup automatically. So manual backup is not necessary. Clear? So this is about backup. Okay. So here with backup, no risk required with Hadoop here. Hadoop takes care of backup. Yes, even big data also, Hadoop will maintain multiple copies. So don't worry about backup with the Hadoop, right? With Hadoop, backup is not necessary. Hadoop takes care of big data also. Hadoop takes care of backup of big data. Next, recovery. What is recovery? Let us see this. Data recovery. So nothing but data recovery here. Data recovery process. Yes, data recovery. Traditional systems. First, let us see traditional systems. Next, we'll see Hadoop. Data recovery. Yes, where is data recovery here? What is the requirement of recovery? What is scenario here? Suppose, for example, here traditional system database server crashed. Suppose your traditional system database server failed, crashed. Database server complete database engine crashed. Database crashed. Means tables, loss of tables and everything, right? Tables scans data. Yes, loss of all the data, right? Because that engine itself crashed. Database, Oracle database engine itself crashed here. So once engine crashed, no data. That case, how to recover that? Just the data, how to recover? For this, there is a backup copy, all right? Daily taking backup, right? So from that backup copy, you can recover it. Now, what's the recovery process? The server has to rebuild. Once database engine failed, server failed, the server has to rebuild. What's the process in rebuilding server here? Yes, what's the process? What are steps in rebuilding server? Okay. Yes, here any server failed here. First team, hardware team. Hardware team will come to picture. Yes, hardware team, they will check for the hardware. Any failure in hardware. Suppose any server failed here. Any server failed, immediately hardware team. First team is hardware team will come to picture. They will check the hardware. Okay. Suppose any hardware sub disk failed. Disk failed here. They will replace the disk, or else completely computer replacing. One more new computer, purchasing new computer. So because sometimes old computer, right? Old computer motherboard fail, many hardware issues. That case they will go for the purchasing new hardware. Yes. After purchasing new hardware. Okay, next. What is next step here? Next Linux team. Yes, because database servers running in Linux base. Next Linux team will come to picture. Now Linux team, they will install Linux base. The server rebuilding is like this. So purchasing new hardware. After purchasing new hardware here, Linux team will install Linux base on the on this computer. After installing Linux here, next step. Yes, they will after install Linux here. Next, they will update OS. Just after installing Linux, we should update it here. They will update OS. Now Linux server is ready. Linux, that system, that computer with Linux base is ready, right? Once ready here, networking team come to picture here. In company networking team, right? Networking team, they'll put the Linux system into network, company network. So how to put in network for this configure? They have to configure the IP address. Next, providing host name. Next, unblocking some port numbers. Okay. A database server running at some port numbers like 3306, 1527. Like there are some port numbers. That port numbers have to unblock. Which are firewalls. Unblocking all that firewalls, right? They will put in network. Now Linux server in network, company network is ready. After that, now DBA team, database administration. DBA team will come to picture. Now DBA team, they will install the database. After installing database here, next database setup. Yes, what is database setup? First they will install database. After they will create instance. After creating instance, simply they will run the scripts. There are some predefined scripts. Once the scripts run here, tables creating, yes, all database objects creating automatically. The scripts will create all database objects automatically. Yes, in database, everything is called objects. Tables are objects, views are objects, synonyms are objects, index object here. Everything is object. Primary key object, foreign key object, everything is objects. Those objects are generating automatically. Yes, once they will run, yeah, once they run the scripts, there are some predefined scripts. The predefined scripts. One script is run here, one script is run, table generating, next views generating. So whatever they want, everything will be generating automatically, right? Not database is ready with tables and everything, right? Next, data. Yeah, this is a backup data, right? Backup data, simply backup data in the backup disk, right? Backup data. Backup data in the disk, right? Not DBA. The DBA here, the DBA guy simply here, he will move the backup data into database server, into some tables. Loading data in table, right? For this is SQL star loader. Using SQL star loader, they will load the backup data into tables. SQL star loader. What is your input file? Next, what's the destination table? Table name and input file. Now, SQL star loader taking backup data file loading into table simply here. The star loader takes care of loading your data in table, right? Like this, each and every table has to restore. Okay, so this is data recovery like this. So once all the data restored in database here, now database service ready, right? After that, now service live, service ready is right. Next after now application admin team here. Yes, app admin team. We come to picture here. They'll start the applications. Once application started, application can access the database here. Suppose application some app using the backend data, right? Now that app can use this data here. Yes, application admin team will start applications here. Then app using this database, right? This is recovery process. Recovery process. 1 second. To work on this recovery process here, first of all, that lead who is taking lead to for the recovery process. First of all, you will raise the RFC, request for change. He has to raise RFC, request for change. Yes, production servers. When working on production servers, yes, we should raise RFC compulsory. What is RFC? I'll explain. Suppose if it's some small request, there is a ticket, simply raising ticket. Small request means running some job. It's a small request. For small request is raising ticket. If the ticket goes to help desk, from help desk, the ticket delivered to concerned team. Concerned team receiving ticket here, they will work on the ticket, right? But this case production servers failures here. That case RFC, request for change. That RFC should be approved by data center director here. Should be approved by director. Yes, for data center this is director. That should be approved by director here, right? Director. For this purpose, this is a process. If that lead raising the RFC, once lead raising RFC, that RFC goes to manager queue. That concerned manager has to approve that. Once approved, that RFC simply goes to director queue. Now director has to approve. Once approved, then this work starts. Okay, raising the RFC, getting approval. After that, starting this work. How much time taking this? We can't see this. Sometimes 2 days taken, 3 days taken, 1 day taken, 24 hours, 48 hours, 72. We can't. Minimum 24 hours required. Get that recovery task, 24 hours required. Minimum 24 hours and expensive. Many teams have to involve here. Hardware team, Linux team, networking team, DBA team, application admin team, like this. Many teams have to involve. It's an expensive. Any server failed here. Recovery task is not easy. It's not easy here. So lot of time required. Many teams have to involve here. Lot of expenditure. Next, lot of time was required. Maybe 24 hours, 48 or 72. So this is recovery task with the, yes, with the traditional systems. Yes, I have seen all the things. With my experience, I'm saying this is okay. Yes, next, when come to Hadoop, what happens here? Yes, let us take Hadoop here. Hadoop. Let me take Hadoop cluster. Yes, in Hadoop cluster, what happens here? Yes, in Hadoop cluster, yes. Suppose this node is failed. What happens? Let us see. This node is failed. What happens? Let us see that. Yes, this node is failed. What happens here? Here in Hadoop, there's a concept of heartbeat mechanism. Heartbeat mechanism. There's a concept of heartbeat mechanism. Yes, every node sending heartbeats to new node saying that I am alive. Yes, I am alive. Yes, every node, every data node saying that I am alive. Okay, this node saying that I am alive, next node saying that I am alive, next node, like this, every node saying that I am alive, I am alive, I am alive. That again, sending heartbeats. This heartbeat interval value is 3 seconds. Heartbeat interval value is 3 seconds. For every 3 seconds, sending heartbeats, saying that I am alive. Now all the nodes are sending heartbeats to name node saying that I am alive. So name node receiving heartbeats, right? Suppose if name node is not receiving heartbeats from any data node, what happens here? So this node is failed. If this node is failed, what happens here? No heartbeats. If no heartbeats, the name node assumes that there is a failure in data nodes. Once failed here, what happens here now? What's the step here? What is next step here? Okay, yes, here, if any node failed, it won't give the heartbeats. If not getting heartbeats, the name node assumes that there is a failure in data nodes. Okay, so once yes identified, yeah, data node failure identified, right? Then what happens here? Now for same data, second copy, third copy available, 2 more copies available. Suppose this node is failed with 100 GB data. In this node 100 GB data or 50 GB data. Suppose this node is failed with 50 GB data. 50 GB data is available, 50 GB data. Suppose this node is failed with 50 GB data, right? That means 50 GB data loss, right? Same 50 GB data, second copy and third copy is available. 2 more copies are same 50 GB data, replica available. Second copy, third copy, right? Then name node will identify another nodes, will identify some other nodes, maybe some nodes. Suppose for example node some 50, some node something like this. Just identifying another nodes. 1 second. Yes, node 50 or some 51, something like this. Suppose node 100. Identifying some node 100. Suppose a very big cluster. There are thousands of nodes here. Suppose here this node is failed. This node is failed with 50 GB data. 50 GB data, right? Now name node will identify the another node which is having 50 free space. Yes, this node is failed with 50 GB. Then name node will identify another node which is having same amount of free space. That means 50 GB free space required. Suppose in this node 50 GB free space available. Then what is next step here? Now name node will give the instruction the second copy node. Name node simply give the instruction second copy node here. Yes, to create replica for the dead blocks. Dead. Okay, for this on this one, right? So simply name node just giving instruction second copy node. Second, yes, first copy dead, right? Second copy is available. Same data is available in the second another node, right? Second copy. Now name node will give the instruction second copy node to create replica. Okay, to create replica for the dead blocks on the another node, right? So you get this dead node, the data simply automatically replicated to another node. So what is happening here? So this is one copy. Next here one copy. This is another a third copy, right? So one copy failed. Automatically the data recurring to another node, right? Yes, once node is failed here, same data recovering using second copy. Same data recovering with the help of second copy. The second copy is just replicating to another node, right? Replicating So what is happening here? Second copy, third copy, and fourth copy. But first copy failed. That means 3 copies. So this copy failed. Now name node giving instruction is yes, this copy node. You can replicate in another node, right? So what is happening here? At any point of time, it will maintain 3 copies. The replication policy default is 3 here. Any point of time, at any point of time, name node always it will try to maintain 3 copies of data. So first copy failed, then giving instruction second copy node to create replica for into another node, right? So this is failed. Then instruction given to another copy, right? That copy node takes care of replicating, right? So here, if any node fails here, the data is replicating to another node automatically. That is called as fault tolerance. Called as fault tolerance. Any data node fail here, the data replicating automatically. The data replicating to another node automatically. That means recovery happening automatically. See, in traditional system, this much of steps recovery process not necessary. In Hadoop, that much is not necessary. Recovery process. Yes, all the teams not necessary here. Hadoop automatically takes care of recovery process. Hadoop takes care of recovery process. Okay. So here recovery is separately, manually recovery is not required here. Hadoop takes care of recovery process. So this is big data challenge. Even big data also recovered automatically here, right? So Hadoop takes care of recovery process. Okay. So manually recovery process not necessary. So this is one more challenge. Okay, one more challenge in the big data. Next solution from the Hadoop. Okay, so this is solution for the recovery, backup and recovery. So backup and recovery. So backup, 3 copies maintaining. Recovery, any node fail, that is replicating to other node automatically here. So automatic recovery, right? So Hadoop takes care of this, right? This is okay. Yes, Hadoop can store any amount of data. There's no limit here. Yes, even big data also can be processed in small time here, less amount of time here. High-end hardware not necessary here. Next, very large files. Very large files. Yes, very large files. Hadoop can maintain very large file also. Next, backup and recovery task. Yes, Hadoop takes task here. Next, disaster management. What is disaster management? This is very, very important. DR activity. Yes, in our company, we are performing this DR activity every year. DR activity. What is DR activity? See, generally here for every data, 2 copies or 3 copies maintained. For these 3 locate 3 data centers. Okay. Yes. Yes, data center 1. So let us say data center 1 this is. So this is data center 1. Data center 1 is some data, right? Next, like this, one more data center. See, other information, there are 2 data centers. One is at Bangalore, other one is Haryana. There are 2 data centers, other information. Like that here, multiple data centers. Data center 1, data center 2, data center 3. There are 3 data centers. Okay, 3 copies for the purpose of maintaining 3 copies. Okay. Now, what are data generating every day? The transaction, daily data is a transaction data. The data may be generating here. Yes, here in this, at this data center, all the data generating. Daily data generating, right? Whatever data generating, the data has to move to other data centers, other locations, other locations, right? Yes. Why these 3 copies required here? Same data but 3 copies. Reason, natural disasters. Natural disasters. Suddenly earthquakes coming. Yes, complete data center will collapse, right? Sometimes power short circuits, fire attacks, right? Loss of complete data center. Sometimes heavy floods. In US, tidal waves. Okay. Suppose tidal wave is a very high velocity wave. If it is hitting any building, that will collapse. Okay. Tidal wave, high velocity wave. 1 second. Yes, in December month, mostly expecting tidal waves in US. So for that reason, here, in the month of September, October, we are perform DR activity. DR activity. What is exactly DR activity here? See, every year data generating here. Okay. Yearly once, whatever data generating here, all the data transferred to another location. Another location. Yes, in our company here, 3 data center. So one is at Chicago data center. Yes, yes, at Chicago, this is. Next, another data center. Yes, at Cincinnati. Yes, Cincinnati. This also, yes, yes only, but is near California, Cincinnati. Another data center. Next, one more data center, Sydney, Australia. At Sydney, there are three data centers. Okay. Suppose any data center fail, no problem. Yes, we have one more copy, 2 more copies available here. Okay, what happens here? Yes, every year in the month of September, October, November, 3 months. Yes, here we used to travel every year on business visa, on-site work here. So September, October, November, 3 months. Reason that business visa valid for 84 days. 84 days here. So here out of 84 days, yes, around 40-50 days for the DR activity. Next, remaining all the days using for KT, they will they will update us. Yes, any new technology they are going to implement here, they will update. Okay, who are interested to update the technology, they will go to yes on-site work. They'll go to on-site work. So once they go to on-site work here, after not only this work here, yes, if anyone wanted to update their technology here, they will take the KT. Yeah, they will provide KT here. Okay, trainers will be there here. Yes, they will call the trainers, they will train us some new technologies. Okay, like that only I got the training on Hadoop. Okay, I got the training on Hadoop. Yes, that was happened 2012 September month. Yes, I went to there. Okay, started taking KT on that here. After taking KT here, yeah, they checked my performance. They satisfied very well. After satisfying it, they recruited me into Hadoop team. They have taken me Hadoop team because of my Java background here. They have taken me to Hadoop team. So 2013 started working on Hadoop. 2012 September month, yes, taken KT. Okay, so because of my performance in 2013, they have taken to Hadoop team and processed L1 visa. So 2013, 2014, 2 years I worked there. Okay, right? After back to Hyderabad and continuing work here. Next year, every year, whenever required, that on-site team we are moving. Yes, September, October, November month. Okay, this year don't have because of current issue. Don't have that. Okay, now here. Now what is happening here? So every year we are taking that backup, the data, right? All the data moving to 2 different locations, right? Yes, for that 45 to 50 days. Yes, around 80 to 100 resources are involving for every team. Yes, every team minimum two resources required here. So more than 50 teams are there. From all the teams, yes, somebody has to travel. Okay, right? Yes, on-site work. Yes, a lot of expenditure. They have to provide the yes maintenance and everything, right? Okay. Yes, providing guest house there. Yes, next every facility they have to provide, right? Say costly. Not only providing facility, yet they should pay extra money. That means on-site salary getting, yet this offshore team, both salaries will get. We are happy, but expenditure for the company, right? We are happy with that because 2 salaries we are getting. Their maintenance salary here, actual salary, 2 salaries getting here. We are happy, but company, lot of expenditure, right? Yes, 60 to 100 members, they are working on this. For all them, expenditure plus time. They are deviating their time to DR rates. That is in case of traditional systems. In traditional systems, the DR activity has to perform here. Disaster recovery activity, it has to perform. But in Hadoop, not necessary. In case of Hadoop, what happens here? In case of Hadoop, there is a master cluster. Between this, there is a master cluster. Okay, master cluster, once you configure master cluster here, whatever data generating here, this master cluster automatically taking this is that master cluster taking data and copying one copy here, next another copy placing that configurations. Once you configure another copy placing, correct? Two copies, one copy here, another copy into another data center, right? Okay, that is daily once. Yes, it happens daily once. Daily once is enough here. At the end of day here, that master cluster will run here, taking data and copying this location and copying this location here. So Hadoop takes care of that activity here. So manually is not required. Manually it's not required here. Traditional systems manual required, but Hadoop not necessary. Hadoop takes that DR activity. That's it. That is Hadoop. That is capability of Hadoop here. Okay. Yes, all these big data challenges. Yes, Hadoop easily can face it. Okay. So these are the big data challenges and solutions for the big data challenges. Okay. 1 second. These 6 points, right? Generally, anyone will explain half an hour. Within half an hour, they'll finish. But almost 4 days I have taken. There are only 6 points since last 4 days I'm talking about because of my experience. Yes, I'm explaining all that my experience here. This is my experience. Okay. See, if I'm going in depth, if I'm explaining my experience, that experience may not be digesting for the freshers. Freshers may not be understanding it. For freshers, this topic looks like very horrible because they don't know. I'm talking about a lot of things, many kind of real-time things. The terminology, freshers don't know about terminology here. Freshers may be struggling with terminology, may not be understanding. Okay, but freshers, that is not, that guy may be understanding, may not be understanding. That is not important. Here, important is here. I have to deliver my experience. I have to deliver that technology, right? Okay, that you have to understand here. Slowly you have to understand. At the beginning, maybe little bit confusion here, but slowly you have to understand. You should get the experience. Okay, here my intention is by the finishing this course, you should be like a 5 to 6 years of experience guy. Yes, you should put up at least 5 to 6 years of experience. Otherwise, no use of my explanation here. Okay. Yes, I'll make you to work like a 5 to 6 years of experience guy. You can put up minimum 6 years of experience definitely. That is assurance from my side. So because of that reason, I'm explaining all these kind of things here. All these kind of things. For freshers, little bit difficult to understand this, but slowly you have to understand. You have to make up. Okay. Yes, 1 second. Backup recovery new nodes will be added. Yes. New node. Yes. 1 second. In cluster, already existing nodes are there. The name nodes. Yes. Then name nodes, looking for the existing nodes which is having free space. Okay. Yes, suppose cluster field, then getting message out of warning message. Cluster field to 90%, that warning message getting automatically. Once getting warning message, Hadoop admin has to add some more nodes to cluster. Maybe 10 nodes or 20 nodes, depends on requirement here. Yes, once the cluster filled up to 90%, once reaches to 90% is here, 90% is user space, then it will raise the, yes, it will raise alert automatically here. Yes, that raising alert to admin. Now admin has to add the new nodes. Okay, suppose any node fail here, then Hadoop, yes, name nodes, looking for another node which is having same amount of free space. If it is available, then the data required to new node. Suppose nowhere available, then raising alerts. Yes, no space available, space is filled, raising that alert. So as per the alert here, that Hadoop admin has to, yes, he has to add some more nodes, maybe 5 nodes or 10 nodes, depends on data requirements. That's it here. Yet, yes, if node is same free space already available here, automatic replicating. If not available, then raising alerts. Okay, but rare case that is, because here of reaching 90% of free space, yes, 90% of user space, automatic raising alert, right? So admin always will try to add the nodes. Admin will add the nodes continuously, adding nodes, adding today 5 nodes added. After 1 week, raise alert. You will add 5 more nodes. After 1 week, again raise alert. Then adding nodes. Continuously will add it nodes here. Yet, okay. So this is how that recovery process. So recovering the existing node automatically here. Okay, next. Yeah. So that's all about this. All that big data challenges like this. They are the challenges and the solution from the Hadoop is like this. Fine. So these all the overview completed. Okay. Yes. Tomorrow we have one more topic. Just like data. 3 V's of data. Structured data, semi-structured data, unstructured data. That kind of things we discuss. Okay. Next. What are the advantages and disadvantages of Hadoop? These topics we'll discuss tomorrow. Once you finished here, then setup starts. Okay, first Linux setup. On top of Linux base, Hadoop setup will be starting here. Yes. Tomorrow will continue. Right? Yes. Any doubts for today? Any doubts for today? Yes, guys. Any doubts? Yeah, documents and everything else, I will share it. No problem. Yes, I will take your mail IDs from the email IDs from the online team. Yes, I'll share you. By the end of day today I'll share it. Okay, I'll take from the online team your information here. All the mail IDs I'll share you. By the end of day, you will get all these documents and videos, everything. Right? Okay. Yeah. So thank you guys. See you tomorrow. Same time, 10 o'clock. Right?